Welcome to the fourth International Symposium on Multidisciplinary Studies and Innovative Technologies. Due to COVID-19, we are holding our symposium virtually. I hope this epidemic will end as soon as possible. Welcome again. Mr. Mohammed, are you ready for presentation?
Yes, sir, I am ready.
Okay. You can start, please.
How much time I have, sir?
You have 10 minutes maximum.
Yes, sir, I will try to best. Thank you. Hi, everybody. How are you? I wish you are fine. My name is Muhammad Imad. I am studying master's degree in Altenbash University, electronic and computer engineer. Is my sound clear, sir? Sir, can you hear me?
Yes.
Is everything okay? Start?
Okay.
Yes, thank you very much.
But your presentation mustn't full screen.
Full
Because
screen.
a technical problem.
Sure. You can't see my presentation.
Okay, I see.
Is it okay now?
Yes.
I try to make full screen.
Yes.
Is it okay now, sir?
I see, but others slides is not appear.
Okay, keep it in this design. Okay.
Okay.
Okay. Thank you very much.
You continue this.
Yes. Thank you very much. My session is to talk about movement schedule function for IEEE 802 time slot channel hopping for wireless sensor network in IoT. So for this one, recently, I think related to IoT have appeared in our life, like in a smart city, in normal life, or industry life. This technology allows smart object things for ability to collect data and sharing with internet. And for this system or this procedure, we need use a low power and remote sensor for this nodes to send this data for the head or the father or the server. So for this one, we need to use MAC address protocol. Yeah, for use this one, we use IP version 6 to add to, to give each node or each device in this system or in this network like IP address to control or to make his duty. For this one, the IP version is too long, the head. So we use something protocol, we call it 6LoWPAN. This protocol makes this head small and easy to send and don't spend any energy or any power and easy to send it. So we use it with this one, IEEE 802 standard. This use low energy and internet capacity. Okay, so the group of internet energy task force. This group debate on energy. Engineering side use IP version 6 with TSCH and IEEE 802 to get more things and more security and would ensure this data to send it. The TSCH is time slot channel hopping, or we can call time synchronization channel hopping. This protocol, or this, how can I say that, use a low power device community with wireless, because we know the wireless is take more power, not like the wire. So we use this device. This device, we don't need it spend more power, just less, because we need it to work a long time, because this power is limited inside, like with battery or any other things. So this TCH use a low power, and this another good things use time division multiple access, and for frequency multiple division multiple access. This use like frequency and time. That's good. We can see it in same time with a different channel. Okay, sir. So there is some schedule to work this protocol, like when I need to start my network or my system. So this is schedule all nodes, or how I can call it, this all device in this system start to listening for the head of, nodes. And these nodes like make some normal and send each node's frequency at time to send this data, to make a schedule between this one. This schedule you can see in this figure. We call the slot frame. This schedule have two dimensions. One dimension for channel, the number of channel is 16 channel we have, and with time, like we can see in this figure, like B sent to node A in this time and this frequency, and another time and with different frequency, D sent to B or C sent to A. This is schedule normal. That's a good schedule. We not there is any lose data or interrupt for data, and we ensure this data will reach. Okay, but we have some, like we can say, statement problem or issue problem in this one. We try to improve it. This one, sometimes the data is delayed, or we interrupt, or we need this synchronization between this nodes and this neighbor. There's something sometimes is mistake between them. So we try to improve this one, and we try some suggested for this one. First suggested is this channel use if I need to make connect with my next neighbor, so I need use the equality. That means I check the noise on this channel. Like I try to use channel number 4. So I check this noise and quality. If it's not good, so I add it to a blacklist. Each node had a blacklist. This I add this channel number 4 is not good for me. So I need added to this one and try to choose another nodes like number 6 or 4 channel. If I find someone good from this channel, I use it. Okay, and I share my blacklist for channel has a high noise with another neighbor. Okay, this first side, and the second side is use the synchronization between this one. Because there is connect time. Each nodes have a 3 state. Sometimes wake up and sometimes sleep. This one, and one is for receive or for send. So sometimes when it is sleep and wake up to send out and connect with your neighbor nodes, sometimes there is misconnect between. There is delay something. So the normal algorithm is make re-synchronization. But if I use this re-synchronization over time, it's not good. And I will spend the power and the delay for data. So I suggest for my research to use check this one, like attract. I attract the derivative ratio clock between the neighbor. So when I attract, I check if this delay is small. So okay, keep it. Not make re-synchronization. If it will be big, this delay between these nodes when open and closed to send and receive data. And nodes number A try to delay slow in this time for wake up to make synchronization with another one neighbor to keep it. And if this delay is too big, so in this time I need resynchronization between us. That's keep it power and keep it synchronization between these nodes and not any interrupt for data or resend for data. That's so that's what so to ensure our work is good or our suggested, so try to use it, implement and split the result in simulation platform. We use NS3 is a simulation for wireless network, and we try each testing along with another one. We check the package delivery and the ratio BDR and power consumer. We can see in figure 1 the average delay. Our suggest and our algorithm, we change a blue line, and the TCH default algorithm in red line. We can see it's our suggest is more better than, and we use the number of nodes. When this system or network, it will be big from 20 nodes, 40 nodes to 100. We can see this drift. Is everything clear? Continue, sir.
Yes, you can continue.
Thank you very much.
I can hear you.
Thank you very much. Okay. And this figure for average day, and this another figure for package delivery ratio. I can reach data for good and ensure to reach this data. We can see this one. I use 20 nodes, 40 to 100, and we can see this our height. And the last one and the most important one is the average energy consumer, because it's I don't need this. My system is made more power. So when there is no recent data or no interrupt, no disconnect between this node, I ensure there is no speed more power to try to join to this network. I will try to resend some data is mistake or interrupt. So when I ensure this one, I will save some power and make it my network good work. Thank you. I try to short my research to give it the time. I'm finished, sir.
Okay. Thank you very much for your presentation.
You are welcome, sir.
Only two participants, you and me. Okay. I wish you success. I wish you continued success in your career.
Thank you very much, sir.
Hope to see you.
Have a nice day, sir.
Okay. Mr. Amir Müstakim. Amir Müstakim, can you hear me?
Yeah, I'm here.
Okay. Are you ready for your presentation?
Yes, I do.
Okay. You can start.
Okay, let me share my content first. Hold on a second.
No. Please, your screen is none. Your screen must be non-full screen.
Wait. Screen.
Don't use full screen.
Don't use. Okay.
Please.
Okay. Can you see my screen?
No, we can't see.
Wait.
Don't use. Please don't use full screen mode.
Yeah, I'm not using full screen. Can you see?
Yes.
Okay.
Okay, you can start.
Okay. So yeah, good evening, everyone. I am Amin Mustaqim from University Technology Malaysia. I'm here to present on my paper entitled Development and Verification of Three-Dimensional Model of Human Foot for Badminton Insole Analysis, a Finite Element Study. So first, let's go to the introduction. A little bit basics of foot anatomy. Human foot anatomy consists of three regions: the forefoot, the front region, middle foot, and hind foot. And as my study is focusing on badminton sports, here's some facts about badminton. In average, in one game, people conduct 50 times of explosive jumping, hence also contributing to also high impact landing on the conducted by player. And also through finite element analysis, localization and internal observation of stress, strain, and displacement can be observed on the specific models of the players. Going on, what is the problem? What is the main issue here is, in finite element method, there are simplification of models in order to reduce time and cost, and this can affect the accuracy of the analysis. And also, up to our knowledge, they are still lacking of attention on badminton sport medical equipment, such as insole, footwear, and so on. So this paper aimed to verify the finite element models with other studies which conducted experimental studies. Going on the methodology, this is the first step. We have our CT scan data, and from the CT scan data, we segmented it, and we generate the 3D models of the bones, skin from the CT data. This is how we get the geometry of the human foot bones and also the skin. For the insoles, we conducted 3D scanning. You can see the scanning process and how the first look of the 3D scan model and the post-process model. So in finite element analysis, every element and models need to be assigned with different material properties. So here you can see that the bone we assign 7300 megapascal and 0.3 of Poisson ratio. Skin with 1.15 megapascal and 0.49 Poisson ratio. Insole with 1.98 megapascals and 0.35 Poisson ratio. Midsole 2.49 megapascal and 0.35 Poisson ratio also. And the outsole, we assign 25 megapascal and 0.42 Poisson ratio. For the we also develop a number of ligaments connecting interbones. So as you can see in the figure, these are the name of the ligaments and their respected bones and their stiffness. We assign on the ligament. the finite element analysis. So in this study, we compare our finite element results with others experimental studies. So the experimental study that we referred gave a load of 270 Newton, and also the load is from in this study, the load was applied from above, and the pink arrow at the bottom as a fix. Going on results and discussion, so here you can see that 17 bones, including 5 phalanges, 5 metatarsals, 3 cuneiforms, cuboid, navicular, talus, calcaneus skin, insole, midsole, and outsole had been developed. For the outsole and midsole, we designed it following the contour of following the shape of the insole. So in this section, actually, our human bones consist of 2 layers, which is cortical layer and cancellous layer. So, but in this study, for simplification purposes, we use only 1 layer of bones. In the other hand, the material properties of the bones, skin, and insole were assumed as a linear material, while in real life, actually, the bones was represented by orthotropic material properties. The skin has a viscoelastic properties, and also the insole, also and midsole, the components actually need to be modeled using hyperelastic models, hyperelastic material properties. So here is the finite element models prediction, and at the right side is the experimental results that we referred. As you can see in the slide, the peak of plantar pressure at the area respected with calcaneus recorded 0.196 megapascal. Looking at the experimental results, the peak was 0.157 megapascal. And also high pressure also recorded at the forefoot area. So in our study, recorded 0.054 megapascal at the first metatarsal head, the lateral side of the foot 0.051 megapascal. So for verification purposes, we observe the pattern of the stress. As you can see, the peak pressure area is in agreement with the experimental works by Wang et al. And also the value of the stress shows no significant difference. Hence, from here, in conclusion, the 3D finite models of human foot based on CT data was successfully developed and analyzed. The bones, footwear components, and ligaments were modeled. And from the results and discussion, it can be concluded that the FEA of the developed models were in an agreement with previous literature works equipment. This is my references, and thank you.
Thank you for your presentation.
Yeah.
Dear participant, do you have any question about this article? Okay, no question. Thank you very much for your presentation. I wish you success.
Thank you very much.
Thank you very much.
Yes, thank you very much.
Hope to see you.
Yep, see you.
Okay. Mr. Ali Evcil.
Hello, how are you?
Do you have any
in fact, my student
was session?
My student was going to present in the third place, Muazu Aliyu Baba from Nigeria.
Okay.
But he couldn't join, I believe. I just joined in to listen to him.
Okay.
I think there may be some problems with joining because I find it difficult to join also.
You can, if you are available, you can present.
I don't have a presentation, but I can use, if you like, the paper and go over it briefly and
Okay.
giving 5 or 10 minutes the topic.
Okay, okay. If you want to do this.
Okay, how can I share the screen? Just press the share screen.
Okay, wait, please. Okay, you can share your screen.
Can you see the screen now?
Yes.
Okay. So the study is about local steel manufacturers in Nigeria. They faced with problems about building collapse due to the corrosion of reinforcement steels. They are comparing the steel they produced locally in Nigeria and also the steels that they buy from other countries. So in this study, our student Muazzu Ali Baba chose two steel production companies in Nigeria and analyzed their productions. His co-supervisor was Isa Ali Yola from Nigeria again, and Mahmoud Savaş was co-supervisor in nearest university. I was also advisor in the project. So the thing is, in Nigeria, the production of steel mainly is conducted using waste materials. In a way, they are recycled materials, and due to different kind of materials they use in the production, the chemical composition of the materials may be different from each other, from batch to batch. Even though you have some standards or you have some kind of average values within a company, there may be different ones from one company to other company or from one location to another location according to the waste raw material they are using. For that purpose, two companies, namely the Katsina Steel Company, Steel Rolling Mill Company, and Sharada Steel Manufacturing Company in Nigeria are taken as samples, and from those companies, steel products collected to investigate their mechanical properties and their effect on building collapse. So the methodology included, of course, the sample preparation, where ASTM standards are used generally, and this is used was 10 millimeters, 12 millimeters, and 16 millimeters in diameter. For tensile test, ASTM E8 is used, where ultimate tensile strength, yield strength, percent elongation, and reduction in area and Young's modulus were tested. In the compression test, ASTM E9 is used, and the compression stress was calculated as the maximum compressive stress divided by the, of course, the initial stress area. And then we have the hardness test, where ESTM E92 is used, and impact test as ESTM E23 is used with notch specimens. Microstructural examinations are also conducted, and chemical composition of the materials are conducted. And from these chemical compositions, CE carbon equivalent value was calculated. So accordingly, the chemical composition of the elements determined to be 0.41 for Sharada and 0.35 for Castina, which are above the levels required. And silicon, manganese, phosphor, and nickel and other chemical compositions are also determined, and their CE value was calculated in comparison. And in a tensile test, we obtained that Sharada Mill Company has a higher ultimate tensile strength of 621 when we compare to Castina. Similarly, yield are the same, but elongation for Sharada is lower, showing that Sharada is producing more brittle materials when compared to Castina. The hardness values are also calculated in Vickers, and Charpy test results are also visible in those tables. So according to this, we might make the conclusion that the chemical and mechanical properties, the chemical analysis revealed that both steels contain more carbon than recommended by ISTM and Nigeria standards. The tensile strength was found for Castina as 621, which is and yield as this one at 472. The tensile stress was fulfilled by the Sharada mill. However, the yield strength of Castina samples remained below the limits given in the standards. So finally, it can be recommended that the authorities should enforce the strict laws and regulations to guide and control the production and application of steel reinforcement bars for the construction sector in Nigeria, and optimum conditions and safety must be maintained. So these are the things that I could share with you. Is there any question that I can answer?
Okay, thank you for your presentation. Dear participants, do you have any question about this article? You can ask to Mr. Ali.
I change the host to you, Mr.
Okay. Hope to see you. I wish you continued success in your career, Mr. Ali. Evgeny.
Thank you very much, Mr. Bekir. Wish you to see you next time face to face.
Inshallah. Okay, the other paper is Ali Abbas El Shupravi is here. Ali Al Saadi is here. Ammar Hatem Almarzoge, he is here. Anafal Zanganavi is here. Okay. We must wait the participants who must present their presentation. Mrs. Nazik Jamal, do you have a paper in this section?
No, I don't have the paper now.
Okay.
My
Okay.
session will be in Saturday,
Okay.
but I want to see the presentation for other participants.
Okay. Okay. Or participants are absent. They didn't connect the session.